Good afternoon, all. For today's lecture, we will start from the operation on the processes. Okay, in the last lecture, we have seen about the scheduling queues, then context switch, then there are the different types of the schedulers like a short-term scheduler, long-term scheduler, and the medium-term scheduler. Okay, and for the today's lecture, we will start from the operation on the processes. Okay, so there are the two major operations we can perform on the processes. So the first one is about the creation of that process, and the second one as a termination of the process. Then the question comes or arises that how we are going to create any kind of a process and how we are going to terminate it. Okay, so in today's lecture we will see how actually we are going to create the process and how we are going to delete the process or the terminate the process. Okay, moving to the next slide, the process creation. We will go one by one. The parent process state children processes, which in turn create other process, forming a tree of processes. Okay, so the original or the main process is called as a parent process, and when the new process that called by that parent process is called as a child process. Okay, I will repeat it again. The original or the main process is called as a parent process, and if that process is going to call any another process, then that becomes a child process of that parent one. Okay, and like this one, the tree of the process is going to be formed. Yes, so this is the about the process creation when the main process or the original process is called as a parent process, and when that parent process is going to call some other process, then that is called as a child process, and some these are the forming of the tree of the process. Okay, then next point, generally process identified and managed via process identifier. Okay, so just like every student is having the roll number or the enrollment number for the exams, just like that one, every process is having the process id, and which is called as a pid. Okay, which is called as a pid. Everyone can hear my voice, Swapnali?
Yes, sir.
Okay. So every process is having the permanent ID for that process up to from the creation of that process and up to termination of that process. So that is called as a PID. Okay. Then about the next point, a process requires a certain resources, just like a CPU time, then memory, files, IO devices to complete the task. Okay, so these resources can be shared between the parent and child. Okay, or the child process can share the subset of the resources, means required resources only shared by the children process, not all the resources are shared by the child process. And sometimes parent can deny that the child process is not going to share anything from the parent process. So that depends on the parent one, how the resource sharing is going to be happen. So for the resource sharing, we are having the three options, like the parent and child can share all the resources. The child can share the subset of resources, means not all resources are shared by the child process, but some of them are shared by the used by the child processes. So that is this another option. And the third one is nothing but the parent and child share no resources, means there are the different spaces allocated and different resources are allocated for the parent and child. So this is nothing but the for the resource sharing. Then next about the execution option, how the parent and child process is going to be executed. The parent and child execute concurrently, means the parent process and child process can execute simultaneously by the CPU. What is meant by the concurrently? Means we cannot say the parent process is going to be executed first and then the child process. Okay, here it executes the concurrently, means simultaneously the children may be selected first of all, or the parent may be selected, or the sequence may be like this one, the parent or child, but this execution is concurrent execution, parallel execution is there between the parent and child. Then another one, the parent wait until the children terminate. Okay, if we are going to use the wait system call in the program, then parent have to wait up to children is going to complete its execution. And when children sends any kind of a signal to the parent, just like children has completed its execution, then parent is going to be executed and then it is going to be terminated. So how we have seen the three options for the resource sharing and two options for the execution of the parent and child process. Okay, I will repeat it again. For the resource sharing, we are having the three options. Just like parent and child can share the resources, the child process can share the subset of the parent resources, or parent and child does not have any kind of sharing of resources in between them. Okay, the another option is about the execution option. The execution option, the parent and child can execute concurrently, or the parent can wait to for the child termination, and when child sends the signal to the parent that child process completion completed its execution, it is going to be terminated, then parent is invoked again, and it is going to be completed all the tasks for the parent process. So this is nothing, this is about the process creation, how the process is going to be created. Okay, if we can imagine how the things are going to be done, and how the tree of process is going to be created in the Linux. Okay, so on your screen you can see this diagram, that is the init process is going to be called first of all, means when the Linux is going to be invoked and Linux operating system is going to be start, then which kind of a processes are going to be created. Okay, so here you can see this is the data structure called as a tree. Okay, that we have seen into the data structure. This is the tree is the one of the type of the data structure, and here you can see the diagram for the Linux system boot sequence. So first of all, the init process is going to be called, then the PID process ID for the init process is 1, then after that the login, kthread, sshd, these three processes is going to be invoked. Later on the bash is going to be invoked. After that bash invoke the ps and emacs, then the thread is going to be called the another process, then sshd is going to be called another process, and this one. So this is nothing but the forming of the tree process. Okay, you can take the any kind of a different exam for the different operating system, just like a Windows or the Solaris, but this is the sequence how the process is going to be created. Okay, and easily you can understood that this is the child process and this is the parent process. Okay, we can simply say login is the child of the init process, or init is the parent of login process. So this is the relation between the different kind of a process. So we can call this is the parent process. Again, bash has the child process for the login, and the login is the parent process for the bash. So this is the relation between the child and parent processes. Okay, moving to the next slide. Then how process is going to be created, and what about the address space? Okay, so if in there are the two things happen between the address space, that is the child duplicate of the parent, then the parent address space is copied by the child, means all the variables that we are using in that program, that is going to be copied by the child and create the duplicate environment as such as the parent. And the another possibility is that this is the first possibility. The another possibility is that the child has program loaded into it, means there is a no address space sharing between the child and parent, there are the different address space is going to be created for the child one. So that is nothing but the address space creation. We have the two possibilities between the parent and child. Okay, then okay, we have talked about how we are going to create the parent process, we are going to create the child process, but how it is going to be actually created by the programming language in the Unix environment or the Linux environment, that we have to discuss now. Okay, in the Unix environment, the fork system call is going to be used to create a new process. Okay, how it is going to be used, we will see. Okay, and this is the another system call used in the program for the creating the process. Okay, the difference between the fork system call and exec system call is that one, that exec use separate memory space with a new program. Okay, means when there is a duplicate of child wants to create the duplicate like a parent, then we are going to use the fork system call. And if I want to use the different memory space for a new program or the new process, then I am going to use the exec system call. Okay, the process creation is done by the fork system call, but when I want to use the different memory space, then I must use the exec system call. Okay, so in the diagram they have shown here, that is the first of all the fork system call is used. The fork system call is nothing but the parent. Okay, here the parent process is already running, but the fork system call creates the child process. Okay, where the child is created, child uses the exec system call to create the new memory space for this. If exec system call is not going to be used, then same address space is going to be copied for the parent and child. And when the child is going to be exit, okay, at the end of the every process, the exit system call is going to be invoked. To what purpose? To terminate the, simply to terminate that process and to release the all the resources and the memory space acquired by that process. Okay, and after that exit, okay, means here we understood that the child has completed its execution, then again your parent process is going to be resumed here. Okay, so this is the understanding for this diagram, that the fork system call, the parent process is running already, the parent calls the fork, then child process is going to be invoked, then exe system call is used for creating the separate memory space, and then the completion of the child is indicated by the exit system call. And after the execution of the child, then parent again resumes and completes its execution. So this is nothing but the parent process creation diagram for the Linux operating system. Okay, then okay, we have seen the diagram. Now we know about the which system call we are going to use. Then suppose I want to use I want to create the one program in C language to create the we want to create the parent process and child process, and I want to see the execution. Then how I can do that? So this is the program for the creation of the process. Okay, and here what we demonstrate, we are demonstrating the parent and child process are different one, and how it is going to be created. So the needed files that we have declared here, that is the stdioh unistd.h, then sys types.h. This is required for the structure that we are using for the PID. Okay, we have seen the structure that we have declared in the Unix operating system. For every process is having the structure, and that structure is defined into the types.h. So we need to include that one. Okay, here simply we are creating the object for the that structure. Okay, then in this line the PID is equal to fork. Okay, this is nothing but the fork a child process, means here the main parent process is going to create the child process. Okay, if PID is less than 0, means when we will get the PID less than 0, if any error occurred, means there is a failure in the creation of the process. Okay, then only the PID is less than 0. If it equals to 0, then it is a child process. Okay, when the PID is equal to 0, then it is a child process, means process is created by the fork and it returns 0 for the child process. Okay, remember that. I will repeat it again. The process is created by the fork system call and it returns the 0 to the child process. Okay, then here simply we can call the exec system call, or simply we can print up this is the child process. Okay, and else it is the parent process. Wait here to child to complete, we can put wait, or maybe we cannot put here wait to complete the child process, and simply we want to print the child complete, and we can print the PID for the your parent process ID. Okay, so this is the simple program to create. So what exactly you will get at it as a output, and finally we have to return the 0. That is the structure for your C program. Okay, what is the output of your this program? Okay, so everyone, you have to all of you know that how you are going to execute the C program. So you can take the screenshot of it and you can run this program, and you need to say me the output of this program. Okay, uh, as a thing, I will show you the simple program related to the fork system call here. Okay, if you go to Google, then the simply you can search for the fork, how the fork is going to be work in the C. Okay, you will get the different kind of examples here. Simply you can click on the play. This is the website called as a jigs for jigs, and which is having the different examples for the fork: int main fork hello world. Okay, here you will get the hello world two times, because it has created the two processes. One hello world is for the parent, another one is for the child. Okay, then you have the 3 times fork. Then what actual output you will get? Okay, you will get the output 8 times. Okay, means simply you can make the formula like n is equal to 3. How many times the fork is going to be called? N is equal to 3, and 2 raised to 3 is equal to 8. You will get the output at the 8 times. Okay, then how it will get? Okay, so the explanation for that is given here. That is, the first parent process is going to create the first fork, is going to create the two processes. Again, that two processes is going to be called the, there will be a second child process. Okay, again it will cause the fork here, and there will be, now it is created by the line 3. There are the 4 processes. Okay, means how many times that hello is going to be executed? This 4 times. This, now it is a 4 plus 2, it is a 6. This is the 7, and original by the main process, it is the P0, means total number of times it is the 8. Or simply we can apply this formula: 2 raised to 3 is equal to 8. So there are the different examples are given for the understanding of the fork system call. Okay, so to run the program, C program, you can go on the Google, you can simply type the C program run online. You will get the different online editors here. You can open any of them. So I will first of all click on online C compiler program is. Okay, here it is, and just you can copy, or you can write down the program that you want to run it here. Okay, this is the program. I have included the files first of all, then void fork example. This is the function we have called it from the main. Then we have to declare the PID is equal to fork, PID is equal to 0, means now the fork is going to be called the parent and child process, and then when it is 0, when the child process is executed, it returns a 0, means child has PID as a PID as a that number that you want to declare. And the child and parent number is going to be print it here. Okay, so this is the sample program, you can see it. I'm going to run it now. Okay, the output you can see it at the right hand side. Okay, we will wait for the output. Okay, so output is parent has PID 63250 and child has PID as a 0. Okay, so two times we have click on the run, so the two time execution has been done, and every time the PID is going to be changed because the process at that point of a time the PID is this one, now the PID is this one. Okay, the for the parent process when it is going to be executed, then it returns the integer number, any integer number greater than 0, and for the child process is going to be completed, the PID is going to be written as a 0, and when there is a minus 1 minus, PID is in a minus if there is a failure in the process creation. Okay, so this is the example for how we are going to create the process. Now I hope all of you have understood this one, how we are going to uh, create the process by using any kind of a C program, by using the fork system call. We are using the exec here. So this is nothing but the how we are going to create the simple uh, parent and child process by using the fork system call. Okay, this is the another program that you not need to refer, so you only refer the only first one. Then this is the another thing how we are going to terminate the process. So process termination is done by the exit system call that we have seen. Then it returns data child to parent via wait. Okay, if there is a wait system call we are going to use it. Okay, then the parent is going to be wait for the child to complete, and then parent is going to be executed. Then at the exit system call is going to be called, then the process resources are deallocated. All the process resources are deallocated by the operating system, means operating system is going to deallocate all the resources acquired by that process. Okay, then another how the another way to create terminate the process, the termination of the child process can be done by using the abort system call also. Means why the parent process is going to abort the child process. So there are the some reasons they have listed here. The first reason is about child has exceeded the allocated resources. Means child process are going to use the more and more resources from the allocated resources. So the child process, for example, we can take that child process has allocated the three resources, but it requires now 4, 5, 6 more than allocated resources. Then child has to abort the parent has to abort the child process. So that is the first uh, possibility. Then second possibility, task assigned to child has no longer required, means task assigned for the child process is not required, so simply the parent process can abort the child process. Then next one, parent is existing, operating system does not allow child to continue if the parent terminates. Okay, so when the parent is already terminated, then child is going to be no longer exist in the operating system, the child is going to be automatically aborted or automatically deleted from the operating system. So this is about the process termination. In the process termination we are going to use the exit system call. Wait is used to wait for the child, then parent is going to execute, the all the resources are deallocated by the operating system when we are using the exit system call. In which another circumstances the process child process is going to be terminated when it exceeds the allocated resources, when there is a no longer required of the child process, the parent can terminate it, and if parent is already terminated or end, then child process is not going to be stay in your operating system, it is automatically going to be terminated. So this is about the process termination. We will go to the next slide only. So there are the more concepts for the process termination. Some operating system do not allow child exist if parent is going to be terminated. Okay, we have discussed it. If process terminates, then all the children must be terminated. Okay, then what is meant by the cascading termination? All children, grandchildren, etc. are terminated. So this is nothing but the cascading termination. Okay, when we are thinking about that one, when the parent is going to be terminated, all the child process is going to be terminated. So what this term is going to be called? This is nothing but the cascading termination. Means one is going to be terminated, then other processes created by that process is going to be terminated. So it is called as a cascading termination. The termination is initiated by the operating system. Okay, this is initiated by not any kind of a process, it is initiated by the operating system. The parent process may wait for termination of a child process using wait system call that we have discussed. If no parent waiting, so that process is called as a zombie process. Okay, if there is a waiting for the any kind of a child process, then that parent process is called as a zombie process. Okay, remember this word, this can be asked in your MCQ also. And if such kind of processes, those processes are not having their parent process, means parent is already terminated, so that is nothing but the orphan processes. Okay, just the meaning of that word, that is the orphan. So the process those are not having the parent processes is called as orphan processes. Okay, moving to the next slide. Okay, this is the simple example for the multiprocess architecture. For the multiprocess architecture, we can take this example in the browser. The browser is the one program. When we double click on that browser, that program becomes a process, and in that process we can have the multiple processes. Like we can open the many browsers, we can use the different plugins here, we can use the different renderer here to execute the scripts. So this is the example for the multiprocess architecture. Okay, next one. So this is the last point to discuss about the today's lecture, that is nothing but the inter-process communication, how we are going to communicate between the processes. Now we are going to understood about the whole thing about the process, how it is going to be scheduled, how it is going to be created. If there is a communication between the process, then how we are going to communicate it. Okay, the processes will go one by one. The process within a system may be independent or the cooperating. Independent means there is a no need of the communication, the process is going to be exist alone and it is going to complete that process alone only. There is a no sharing of data, no sharing of the resources is going to be required. Okay, and there is a no communication between the any kind of a process, so the process stand alone is called as an independent process. And what is meant by the cooperating process? So there is a need of the message passing, there is a need of the communication, so that kind of a process is going to be called as a cooperating process. Okay, then cooperating process can affect and affected by the other process, including the sharing the data. If there is some kind of a sharing of the data it may happen, then it is nothing but the cooperating process. So reason for the why there is a need of the cooperating process, why we are not going to be run all processes independently. Okay, so these are the four reasons. Information sharing. Okay, when we declare the global variable, okay, that is going to be shared by the all the functions, so the need of the information sharing. Then the computation speed up, we can use, there are the multiple threads in may exist in your program and that we can run it concurrently. So there is a computation speed up is going to be happen by that operating system or that system. So there is a need of the computation speed up. Then modularity. So first of all we need to write the different modules, the whole code we are going to divide it into different modules, and for the simplicity purpose the modularity is going to be used. Then when we are doing this all modularity information sharing, then convenient it should be convenient for the user. So the convenience is also going to be increased by the cooperating processes. Okay, then how it is going to be done? So by using the inter-process communication, that is nothing but the IPC, inter-process communication, we are going to use the cooperating processes. Okay, so in this phenomena, interprocess communication, these two concepts are used, that is the shared memory and the message passing. Okay, how it is going to be used, okay, we will see it into the next lecture, and we will continue for the further points. Now if you have any kind of a doubt, so you can ask, because the many conceptual points that we have covered into the today's lecture. Okay, now we'll stop for the this lecture. Okay, if you have any kind of a doubts, you can ask.